Imagine you are due for a gift from someone. Think what happens if he gives you 50% of a new shirt or 50% of a phone. Will you accept the gift? Or will you go to buy 50% of a car just because you can't afford the whole of it? 50% of anything is equivalent to broken. It's of no value basically. 50% is equal to 0 in almost all the objects, except for the case of the brain. It has the innate ability to reorganize or reorient itself, which makes the analogy of the brain with that of the computer a myth. Your brain is not a hardware, it's a liveware. It's dynamic and it's changing. Your brain is not the same as it was when you hit the play button of this video and by now. It is not only that your brain shapes you, it's also you that shapes the brain. That's the basis of neuroplasticity, the topic for today's discussion. Welcome to today's presentation in the Brain Belief and Immunity series. Today we will talk something about the innate capability of the brain to reorganize itself. That is neuroplasticity and its possibility in our daily life. To start with, let's see whether a person can be functional and lead a normal life with half of its brain missing. How much skeptical might it sound? There are indeed reports of such individuals who lack a part of their brain, like this girl, Jody. So, what happens is that she lost half of her brain at the age of 3 due to a severe medical complication, a rare form of encephalitis. She is leading absolutely a normal life when she grew up. You can watch her in the YouTube as well. And this woman, Christiana Sandhaus, lost half of her brain when she was 8 years old, again due to a severe medical complication leading to over 150 seizures almost per day. Christiana even completes her master's degree and now a professional speech therapist. Here is the report of another girl who even didn't have a clue that she lacks completely a cerebellum, the critical lobe of her brain, containing more than 50% of the neuron, the nerve cells that makes the brain. She didn't know it until she have done a CT scan at the age of 24. Now these are only some of the cases where the brain plasticity is at its best. But this always happens to the common people like any one of us, and for the many people who have lost some of its vital functions, like vision, say. We see with our eyes. Okay, not really. Eyes are just the receptors. We see with our brains. The eyes actually collects the information of the light waves, and it sends it to the back of the brain in the visual cortex over here, where the image is processed, and that's what we actually see. For those who are blind, there are no sensory inputs from the eyes that can lead towards this region. Hence, this region is devoid of the stimulus from the eye, and then it is designated for certain other jobs that seems to be crucial for that person. For example, understanding the speech or understanding the sound. Functional MRI scan by the scientists of the Johns Hopkins University have shown that the blind people can use the sense of sound like speech, etc., through their visual cortex. Actually, the sound is processed over somewhere around here, the auditory cortex. But for the people who are blind, they can process the sound in their visual area. Even when the blind people are trained to read Braille, except for the developed sense of touch in the sensory cortex of their brain, the Braille reading activates the brain region that has been designated for vision, the brain visual area. That is the area over here at the back of the brain. Hence, our brain is not only plastic in nature, but it is intelligently plastic. A famous study in this aspect was published in the prestigious Journal of Science in 1988 by an Indian scientist, Mriganko Shur of MIT. In this study, Professor Shu redirects the nerves from the newborn ferret's eyes to the auditory thalamus and the cortex, the region of the brain designated for speech or the processing of the sound informations. As the newborn brain are most neuroplastic in nature, when the ferrets grew up, they could see normally as any other member of its species. But its image processing station is changed to the region in the brain designated for processing the sound. It is conceptually kind of having three switches, one for a fan, one for the light, first light, and the another for the second light. Now by changing the wiring and the circuit, we can manipulate the switchboard in such a way so that now the fan will turn on by this switch and not by this switch, which was initially been designated. It is kind of similar like that, but the brain, remember over here there are three wires, the red, black and blue. But in the brain there are 86 billions of neurons and trillions of networks and the connections between them. Its complexity is basically unfathomable. Our brain is basically made up of these tiny cells called neurons or the nerve cells. These neurons, almost 86 billions of neurons, made up our brain and their connections and make a complex network over here, the trillions of network, more than the stars in the Milky Way, with all the chemicals in between in one brain. So what this neuroplasticity basically means is the ability of the brain to reorganize or reorient itself, both in terms of the structure and in terms of its function. And it can be modified by actions, by the thoughts, by the behaviors, by the social influence, and many other factors. Basically everything outside and inside of you. This neuroplastic change can be both functional and can be also structural, and is driven by many factors that I have already told, that like traumatic events, like stress, like social interaction, even the meditations, the emotions you have, the new experiences you gather, the things that you pay attention to, or even the new learnings, or the diet, or the exercise. All the factors drive our shapes or reorients or reorganize our brain. So it is mostly predominantly our brain is neuroplastic at the beginning of our life. And neuroplastic change can also happen post brain injury that we have already discussed, and even in case of the normal adulthood, like it can help to change when when any of these driving force are present. The two key mechanisms that drive this neuroplasticity, one is synaptogenesis. It is the connection pattern between the neurons, these nerve cells, the neurons. In a newborn child, it is loosely connected, like over here. And as the baby starts learning new things, new skills, actions, activities, or the way this baby is brought up, all influences the connection or the network pattern over here. And after a certain age, the unnecessary connections that are present over there are pruned off. This is the second mechanism, the synaptic pruning, which means the reduction in the number of the synaptic connection. It is there to make the brain more efficient. The brain is prone to the highest level of neuroplasticity, as already discussed, in newborns and infants. That's why the learning curve of the infant is the highest, because these loose nerve cells can connect with each other and can shape the brain accordingly. And the way they brought up and the trained shapes the person that they will be. It's because of all these free neurons that they have. And these neurons, free neurons, are ready to get connected to any change or training. In fact, anybody can be trained to become a genius if proper inputs are provided at the critical time. To prove this idea that no talent is inborn, no talent is God-gifted, and no one is actually comes with something or can be termed something like prodigy, we must look into the Polgar sister experiment. This is a classic real-life experiment of neuroplastic change in the brain in the infants. And this experiment proves beyond doubt that geniuses are not what people born with. It is what people actively acquired. Nothing is God-gifted. It all depends on the multifaceted factors that shapes the brain, and that is much easier doing in infants. Believing these facts, this person, Hungarian educational psychologist Laszlo Polgar, want to prove this belief that any child can be trained properly, if trained properly, can turn into a genius. Although he was asked by the government officials during 1960 to consult a psychiatrist to get rid of this delusion, he was determined. Laszlo wanted to do these experiments on his own child, and for this he wanted to get into the marriage of contract with any potential partner who liked to participate in this experiment. After sending a lot of letters to the ladies, a lady named Lara agreed to marry Laszlo, keeping the contract in mind that their kids will be trained to be genius. Their first girl, Susan, was born in 1969. Laszlo thought about the domain over where she will be trained to be the genius. He chose chess because performance in chess is most objectively measurable, unlike that of writing or singing, where the quality is not have any strict measurable scale. In 1974, the second girl Sophia born, and in 1976, the third girl Judith was born. All were trained in chess, not forcefully, but creating the passion and the interest. Because apart from that, the true passion or interest from within, nothing can grow above a certain level. Remember that in that time, chess was completely a men's monopoly. Let's see how these three girls performed in chess. Susan, the oldest of the three, was the first female grandmaster. In 1991, she became the grandmaster. She won 4 world championships and 5 chess olympiads, and first person to win the chess triple crown. Now about Sophia Polgar. She won the gold medal under the age of 14. Her most remarkable achievement is the sack of Rome, where she won 8 straight games against the grandmaster at the age of 14. And she was ranked, her highest ranking was 6th ranked woman in chess. Judith was the youngest grandmaster at the age of 15, taking both male and females combined. She was the #1 player for a decade and the greatest female player of all time. So, even after this, the critics told it might be a coincidence, and it only stated that the Polgar sister and few others stated the Polgar sisters are prodigy, the very notion Laszlo was fighting against. Laszlo stated that the people didn't know how many thousands of hours and how impatiently slow growth is for all the girls, and those who highlight any chance of genetic influence, for them Laszlo was just an ordinary chess player only knowing the rules, and Clara didn't play chess ever. So anybody interested to know more about this Polgar sister experiment, about these 3 wonderful sisters, can visit these videos, and this is one of the talk over there, and this book is on this experiment on their life. What actually happening when we are actively learning and repeating an action or thought is that the network forms, the network of the nerve cells in our brain, that is the neurons, and such complex network is only stabilized by repeated firing of the same neuronal pathway, which leads to the famous saying that neurons that fire together wire together. It means in the other way round, if 2 neurons, this neuron 1 and neuron 2, fires at the same time, that means that they are connected or wired somehow. Less use of a neural pathway, for example over this neuron with this neuron, will cause the decay in these synaptic connections. And the pruning of such connections, the synaptic pruning, do happens. This means either you use it or you lose it. And a pool of chemicals called neurotransmitters in between also plays role in establishing these neuronal connections. They are called neurotransmitters as they facilitate the transmission of neuronal signal from one neuron to the next within the gap, the synaptic gap. As you are learning these infos, new synapses are being formed in real time right now in your brain. That is, your brain is changing. What is the actual basis? That is the actual basis of neuroplasticity. To look into how learning can affect such changes in the brain, this remarkable experiment done by a group of scientists and published in prestigious Journal of Proceedings of National Academy of Science, PNAS, the brain scanning was performed on the applicants for the London taxi driver position. And their brains were scanned both before and after the rigorous training that they have gone through to get the license. They have to develop the navigation skill, memorize every lane and bylanes in the city and the shortest route between any 2 points in the city. So after this rigorous training, what the scientists found is that these trainees, through this training, changes their brain structure literally, increasing the size of the posterior hippocampus, the region which is one of the important for the navigation and for storing of the memory of the brain. The neural circuit over there increases and their size literally increases. Any sorts of learning and repetitive action has immense potential to change your neural circuitry and proven beyond doubt in numerous experiments, both in case with the animal model and with humans. With whatever we learned or memorize or do changes the synaptic connections over in the brain, and these changes are in the cortical motor map representation of the body also do happen. However, a Harvard University study have shown the highest potential of the neuroplastic change is as expected during the infant years, which drops as we get older. Hence, to have the similar change in our brain circuitry, the effort to learn or change increases, and after the age of 30, at the age of 30, this effort will surpass the observable neuroplastic change. Generally, many people stop learning or loses interest towards adapting to the new thing after the age of 30, as for them, the effort seems to be greater than the neuroplastic change or their actual behavior or the personality change or the learning for the new things. But the good sign is that your neuroplastic potential never hits zero. So anybody willing to put a little extra effort will get the benefit out of it. Developing skill for the new language in the kids seems to be easier than when we get older and we try to learn some second language because of the same reason as discussed. However, anyone learning a new language at whatever age it might be or learning anything can cause an impact on the neuroplasticity, as been studied over many times by different groups of scientists. This is the human brain. The person is looking towards you. Hence, this is the left hemisphere of the brain and this is the right hemisphere of the brain. And as we know, the left part of our brain controls the right side of our body and vice versa. Hence, this green colored region of the brain is called the somatosensory area for the right half of the body. Somatosensory means the body sensation. Hence, every part of this green region, this area, senses body sensation from different regions, and according to the use of the body part to detect this sensation or by action, the area designated for each of the body parts changed. It alters. Like right-handed person will have a higher right hand representing area than its left side counterpart. This blue colored region is the motor cortex, which again controls the motor activity or the movement of the respective parts as labeled over here. Note the groove between this green and the blue is the central sulcus. The lobe in front of that is the frontal lobe, which is the unique for human, that makes the human, and the parietal lobe is in the back. Now if we draw a human figure basing on its representation in the brain, then it will look something like this. It is called homunculus. Note, as our hand is the most sensitive area of our body for the touch and for sophisticated motor activity like writing, which your toes cannot do, its representation in the brain cortical area is larger. If someone starts to write with the leg, then this repeated action will increase its representation in the brain accordingly. For example, the football player who needs much more controlling capacity by their feet has their larger representation of the feet in their motor area of their brain, and this representation of the area is malleable and it changes according to the use and disuse of particular organ. But this is another classic representation of how the brain plasticity works. The same is true for the cortical map of the hand, the area designated for the hand in the motor cortex of the drummer. They have a larger representation because they need the fine motor movement of their hand. It means with constant practice, with whatever practice you are doing or the action you are doing, actually change there has an effect in changing this representation or the map in the brain or the area of the brain or the real estate in the brain designated for that particular action. Now, what will happen if someone is devoid of some body part? It can be, say, a hand in case of an amputee. In case of an amputee who, say, lost one of his arm, there will be no senses to be sent to its represented part in the brain, right? But the brain hates vacuum. Its neuron and the connections are expensive. They will not sit idle. The brain will try to modify it by letting this vacant space to be intruded. Over here you see the arrows, to be intruded by the other sense organs or the other sensations. You might be aware of this when you find that a person lacking the vision might have very well developed touch or smell perception. The vacant cortex in the brain then reallocated for some of their functions. That one of the main reasons for which a person lacking a particular sense has a tendency of having a sharper sense in other aspects. Now let me introduce you with the concept called phantom limb and the phantom sensation that is felt by 70% or more of the amputees. That is, they feel the presence of the hand or the limb that is not there in the first place. Even they complain about the pain and the cramp in the hand that is not there. How it can happen? For that, imagine you wake up from the sleep with a severe pain in your right hand. When you complain about it, I tell you that it's only in your head. However rude it sounds, that's the truth. Whether pain sensations we are feeling, it is due to whatever the pain sensation it is due to its pain interpreted by your brain. For that interpretation, the sensory inputs are only provided by the sensory receptors from the site of the other part of the body. If somehow that interpretation can be stopped, we will not feel the pain. Even if it is there in the site, the mechanism by which the painkiller works. Now, for the amputees, the brain gets triggered in the cortical map region that previously represent their hand, the limb that is not there anymore. And the brain starts feeling the cramp. Now, to get rid of the cramp, Indian neuroscientist V.S. Ramachandran cured this phantom pain by his famous mirror box therapy. It is called mirror box therapy because the only thing required is basically the original hand, the right hand, and he will force to see only this part in the mirror. So, making the person look into the mirror image of his intact hand, which their pain perceives to be their amputated hand. Then just by massage or physiotherapy on the hand that is actually there in its place, the patient gets the relief from the phantom pain. Remember, the pain is real for them, just like yours, as they have the fully functional brain. Mirror box therapy is a classic example of neuroplasticity, as the brain adopts the mirror image as his own hand. You might think that how a brain, which is such a clever and intelligent organ, can be fooled in such a way. Actually, brain is a fool in many aspects. That is highlighted in another presentation in this series on perception. You can find the link below in the description box. If you are still in disbelief, I will like you to try out an experiment related to this. The basic of this experiment was first performed and published in the prestigious Journal of Nature in 1998. So what they have done, they use a participant over here and letting him sit and block his vision from his original right hand. Instead, they kept a prosthetic rubber hand in front of their vision. Now the experimenter starts to brush both the hands with the help of the paintbrush for a few minutes only. Within these few minutes, brain starts to adopt that hand, the prosthetic hand, and feels like that prosthetic hand as his own hand. As the paper title states, the rubber hands feels the touch that the eye see. So what basically is happening over here is that initially the participant knows that it is the false prosthetic hand, but as the feelings from brushing that hand is getting consolidated and goes along with the vision information of brushing, the conflict began, and soon after that a sudden hammer blow in this prosthetic hand by another experimenter makes the participant startle, and he thrusts away the hand, this original right hand, away from its position in fear of getting hurt, only to understand that there is no pain, and then only it registers that with that thrust of moving and no pain information gathered, then the brain dissociates the prosthetic hand from its representation in the brain. So it is a powerful example that how easily our brain can be fooled and how malleable and plastic it is. If only few minutes is enough to make such a drastic change in your brain, like adopting a rubber hand, think of how a little action can have a much profound impact on your brain. Even a thought can. A lot of YouTube videos like this provided over here deals with this rubber hand illusion. So this is a BBC video, this is a National Geographic video, so you can have a look into it and can even perform this experiment easily. It is a fun, you can try it in home too. But the only caution, to remember which one is the rubber hand before giving the hammer blow. The life of Helen Keller, the deaf and the blind girl, as shown in the movie The Miracle Worker in 1962, is another example how proper influence and training can help in changing our brain activity. For 7 years, Helen couldn't able to see or hear anything, and then in March 1887 came her teacher Annie Sullivan, the miracle worker. In only 1 month of time, that in April 1887, Annie took Helen to an old pump house, that Helen finally understood that everything has a name. Sullivan put the Helen's hand under the stream and began spelling WATER into her palm. First slowly and then more quickly, basically association of the vibrotactile stimulation. Keller finally made his first major breakthrough, connecting the concept of the sign language with the object around her. Here we find that for the first time in the 7 years, the Helen was trying to spell or speak or produce some meaningful sound, the water. And she is now trying to get most of the information and try to associate those informations with the objects, with the vibrotactile stimulation that is provided by her teacher Sullivan. This is the famous scene for this movie where for the first time he understands to associate a vibrotactile stimulation with that of the object surrounding her. Like everything, the neuroplasticity also do have its downside. A key component to fix and stabilize a neuroplastic behavior is the reward. If this reward system is not there, unless your brain is rewarded or getting some feel-good factor, whatever might be the training, it will not lead into or can shape the brain as required to be. For any such change to happen in your brain, you need to think of some sorts of positive reward for the brain. For example, over here, a negative impact of the neuroplastic behavior is if the initial drug experience gives the reward and it is not been regulated emotionally quite well, because the amygdala, the region of the brain which controls our emotion, actually gets the reward more and more, then the prefrontal cortex, which is the unique for our brain, which helps us to think, to judge, to imagine, to make the decision, tries to control this emotional region of the brain. But after such repeated exposure, the circuit of neurons established which makes this craving more and more, and as the people crave for this drug, and as more and more neurons make the circuit depending upon the drug exposure, the more addicted that particular person will be. Think of a situation when you first try to learn something like driving, cycling, typing, how it feels then. You are totally conscious of what you are doing at that time, about where a particular alphabet in the keyboard is, or how and when to change gear, or when to hit which chord of the guitar, or how to balance while cycling. And now it's totally an subconscious experience. You are not aware of how many times you change the gear while driving or when you do it at all. It is happening automatically. So how this happens? Brain is kind of lazy. It tries to free up the conscious space as much as possible. So this conscious space actually means the different behaviors, like the movement of your hand might be choosing something. So the brain tries to remove as much thing as possible to the unconscious. The unconscious is in autopilot mode. Unconscious runs in autopilot mode. It is an automatic mode, and this automatic mode, actually the things that you have learned or repeated for many a times, it might be driving or typing, or might be thinking or ruminating old thoughts behaviors, anything that shapes your personality, all went under the unconscious level, under the autopilot control. So it frees up the conscious space so that of making this repetitive tasks to push into the unconscious level, until you put an effort to making yourself aware to take something out of this unconscious autopilot control to the conscious level. The change is not possible. You will not be able to make the best advantage of the neuroplastic potential that your brain do have if you put most of your feelings, most of your thinkings, behaviors under the autopilot control. Getting rid of the stressful thoughts like anxiety, tension, whatever it is. So any getting rid of any of those stressful thoughts is not stress-free. You have to put stress initially, and after a certain time, that also will become your unconscious, that will also go under your autopilot control. This is a photo of a keyboard. If I tell you to say where the alphabet, the key H is in this keyboard, what are the keys? If I ask you to imagine without looking to your keyboards, that what are the keys that is present to the left and right of the alphabet H key? Probably you couldn't answer right away, or even if you can have to think for it for a couple of seconds. But while typing, you don't need those 2 seconds halt. While typing a sentence, your finger automatically places itself on the key necessary at that moment. Basically, we don't need to remember consciously its position. That's why even using it probably every day in phone, tablet or computer, looking at it every day, you are probably feeling uncomfortable or have to think for it, thinking or trying to dig it out from your subconscious to your conscious level. If you think of the same thing repeatedly for the same, like on the same old past, the brain think of it without taking the control. It will make more stronger synaptic connection for those thoughts. Using brain that is in continuous autopilot is something similar to using an expensive DSLR camera in automatic mode. Of course, it will do its best while taking a picture in auto mode, but that is not what it is meant for. To capture more beautiful picture, you have to take the manual control. Of course, you will mess with it initially, then that also will become your subconscious autopilot control. Brain can of course do its best when it is in autopilot, but that is not again what it is meant for. To make the best out of it, you need to take control sometimes and on some things that is in your head. And if you do so, then only you can change the brain, because the brain is not what shapes us. It is we who shapes the brain by your thoughts, actions, beliefs, social influences, etc. That in turn potentially helps to shape us. There is an old saying called fake it till you make it. Your brain doesn't know to distinguish between the actual event with that of the imaginary one. It's kind of interesting, but it has been proven that same region of the brain fires if you were playing soccer or if you imagine to play soccer, including the visual and motor activity region of the brain. Whatever you are, whether you are actually commuting by a bus or lying in your bed and thinking that you are commuting by a bus, the same region of the brain gets activated. It doesn't know the difference. The brain couldn't able to distinguish that. Whether you are in, for example, whether you are in actual threat or you are thinking of some upcoming threat. So whatever you are thinking, the thoughts, feelings, actions, whatever your mental activity might be, it creates a neural structure. the neurons fire together to make these connections, the synaptic connection. And more you are repeating a thought, a feeling, an action. This repetition of mental activity will lead to the strengthening of this neuronal connection. And once it is strengthened, this circuit has been formed, it shapes you and your behavior, your personality, your unconscious, your autopilot mode. So now comes the interesting question. Do you believe your own beliefs? So it is kind of interesting because even if you don't believe that your belief system can cause such a havoc, that you can basically rewire your brain by your thoughts and action alone, that's also a belief. Your belief of not believing the power of neuroplasticity is itself a belief. So work the initial belief, the first. Work with that, the first belief, and before jumping into the second. So whatever I have shown you over in this presentation is the truth based upon the scientific evidence. So if your belief spectrum doesn't overlap, if it doesn't fit into your belief spectrum and overlap with the truth, it has no value or to push yourself to change your brain. The truth is but what we believe the truth is. So to make your thoughts, your beliefs to overlap the truth spectrum, you have to move out of your comfort zone. Because whatever you think you can or you think you can't, in both the cases you are right, because it depends upon your belief. The belief is the only truth. This is a famous speech by Henry Ford. So if you want something you have never have, like updated brain, then you have to got to do something that you have never done before, as this famous saying is. If you want a new path to be formed over here somewhere in a new direction over here, then you have to act accordingly. You have to leave the old path, that is the old path over here, the old traverse path, and have to walk through the grasses, the rat holes, the insects in the new path that will come into your new path for the initial days, every day until the grasses gave away and a new path arises and the new path paved, kind of establishing a new synaptic connection, right? So between the two neurons of the brain, and more you work, the more and more it got strengthened. And if you left the old path as it is and don't use it, the grasses will grow and the path will ultimately disappear, kind of metaphorically, kind of synaptic pruning. So there is an old saying in my mother tongue, Bengali, Bishwashe milay bostu torke bahudur, which means something like belief can make you achieve things which logic and arguments can't. Even if you believe from your core of your heart something which is illogical, your brain will reshape itself and try its best to make it the truth. Now, I hope you will appreciate this famous quote from Paulo Coelho even more. The quote says, when you want something, all the universe conspires in helping you to achieve it. For you, the universe is the brain. Even the very concept of the universe is generated in your brain. And if you believe something, if you want it and provide appropriate response or action, and if that action, this appropriate response or action based upon a belief, and if that action gives some sorts of positive reward to your brain, it will only trigger or stimulate the belief system more to carry on this response or the action or the routine more every day, so that you are in constant search of the reward. That's why the reward is an important component. So if your response in watching this particular presentation gives any positive reward that might trigger your belief that the wonders within can provide many such positive rewards in future, please do subscribe to the channel. I will update you about my latest uploads. Till then, you can have a look into these neuroplastic videos. This is a 2-minute conceptualized videos, my favorite. This is one of the neuroscientists who studied her own brain basically after the stroke. It's an inspiring talk you may like to watch. These are some of the books in my favorite books in this field. And at last, I must say that train your brain as you are your neurosculptor. Reshape your brain as it shapes you. And finally, a warm thanks to everyone for watching till the very end. Thank you.